ordinary indoor insulation wouldn't work because the line was right next to the interior walls.
Something just happened that prevented me from turning down the request. Newspaper flyers were scattered all over a desk. I looked at the flyers. Black flyers, white flyers, they were strewn all over. First, I picked up the white flyer. I realized that the white ones weren't hot. I immediately placed the white flyer on top of the black ones. And after about 5 minutes, I touched the black paper that had been hot only a few minutes before. It wasn't hot anymore.
He thought if he painted the walls white, the same effect could be obtained in the factory. Ishiko gave it a try. After painting the roof and exterior walls, the room temperature dropped by 3 degrees Celsius. Ishiko realized he'd stumbled across a promising business opportunity. So he started conducting further research, mixing into resin a number of substances known to have insulating effects. He tried titanium white and mica, a substance that transfers little heat, even toilet paper cut into pieces. But he wasn't able to achieve the effect he was looking for. His mind went back to white paint, the source of his ideas, and he wondered if anything could exceed its heat reflection characteristics. Then he realized what such a substance might be.
When I was a kid, I often went out skiing. As it happened, there was a ski slope near the city where I grew up. The whitest thing that I have seen in all of my life is snow.
In the middle of winter, Ishiko got a sunburn while skiing. That's due as much to the snow as to the sunshine. Snow reflects 90% of sunlight, from ultraviolet to infrared.
I thought, if I could use a material like snow that's white to the human eye, but transparent under the microscope, maybe I could come up with something really great.
White but transparent. He found a material that satisfies that condition. Perlite, a ceramic powder made of volcanic rock. Ishiko obtained some of the substance right away. He mixed it in the paint and tested it. Just as he expected, it reflected a great deal of heat. But the breakthrough that seemed so promising drizzled. Literally so. When applied to a wall or ceiling, it dripped. Ishiko thought he might be able to solve the problem by increasing the stickiness of the resin as much as paint would tolerate, but it still didn't work.
Because it dripped so much, I adjusted it so it wouldn't. But after time passed, it kept dripping and dripping. The weight of the ceramic powder was pulling it down.
A solution came by making hollow beads of the ceramic. Glass beads are used as reflective material for white road markings. Ishiko asked the manufacturer to make the same thing with ceramic. The turning point came 5 years after he repainted the factory, when he came up with an insulating resin suitable for sale. It didn't make much of a market impact at first, but revenue grew as word of mouth about the product expanded. The cooperation with JAXA began 4 years ago. The agency recognized the insulation technology Ishiko had developed on his own embodied the same concepts it used for its rockets.
I asked about the actual performance of his technology. He had already commercialized a product with technology that reached the level of our rocket insulating material. A few dozen micrometer hollow beads are used to create insulation. He'd already done it.
Just a year later, a new coating was developed that achieves high performance with 30% less thickness than conventional products. From houses to factories, it's been applied 5,000 times so far. A solution to overheating that is really cool.
One of the great things about this coating is that it's so easy to apply. It can be used in a variety of places. For example, they will paint an entire incinerator in a factory with it, so that if someone accidentally touches it, they don't get burned. Plus, when they go to fire it up again, the heat has been trapped inside, so it's more efficient.
They should put it on fry pans.
Well, no, fry pans are supposed to be hot. But that's not the only benefit. More recently, it's been working on the railroad.
All the long day.
An express train rolls cautiously along. Ice has been applied to the rails. The ice will help return them to the condition they were in before expanding in the summer. Steel rails swell in heat. At one site, they grew 10 centimeters for every 50 meters at 39.5 degrees. Left untreated, expanded rails are an invitation to trouble. A number of derailments around the world have been blamed on exactly that. The best solution for preventing rails from expanding is to keep them away from heat. Nishin Sangyo hasn't figured out a way to change the weather yet, but it is developing an insulation with a rail-laying company. For 3 years, they've been applying test samples of colors and components and observing the effects.
The rail without the coating and the one with the coating have a 5-degree difference in temperature. The differences range from about 5 to 7 degrees. This indicates that we have achieved a solution at some level.
Much of the work is done at Nishin Sangyo's Osaka factory. This lab is the front line of coating development. For rail coating, a material of high heat emission is added, along with the ceramic beads that are used in the company's other insulating resin.
We use powder from a stone called amphibole. This works really well in reducing heat and changing heat to far infrared rays. As a result, we can expect that it will decrease a structure's temperature when it's applied.
However, amphibole powder is heavier than hollow beads. When mixed in the resin, it drips. Unlike walls though, rails lay flat, so the developers thought, no problem. But mixing materials of different weights is a problem. The factory director, Hiromi Takao, tried to turn Ishiko's idea into a reality. Takao has been making coatings for 25 years. She adjusts the speed and the composition of additives.
Yes, this is amazing. We kept saying, really? Can we put some rails? Is it okay? I thought I add different things all the time. I'm interested in what happens, but I'm careful to avoid a mixture in which one part settles. On one hand, I always have fun. On the other hand, I get nervous.
A trial for rail coatings took place at the construction company. The researchers have measured changes of temperature on rails exposed to the sun outside. For this experiment, they use rails they put in a freezer earlier. This rail's temperature is -10 degrees. They raise it to 50 degrees with a heat lamp. A measuring tool reads temperature changes and calculates the amount of rail expansion in micrometers. That could be the measure of safety in operating a train. But one test is not enough. They need repeated results to prove reliability. 2.5 hours after the rail started to be heated, the measurements show the insulating resin is having an effect. Without the paint, a 50-centimeter long segment expands by 0.35 millimeters on average. That's about the same as the original steel. But the rail with the insulating resin has only grown 0.2 millimeters.
I think that the far infrared effect helps keep temperatures down. We have to keep experimenting, though, to find elements that can be changed for better ones, and those that don't need to be changed at all. We still have much more to discover.
Ishiko looks towards adapting the material to bridges and other steel structures. A substance that prevents metal from expanding may help his business grow.
So, Mak-kun, what did you learn from your immersion course in insulation?
That the right kind of insulation can cut energy cost and carbon dioxide emissions.
That's right. It can make things more comfortable for you, your wallet, and the planet. Plus, it might just help Japan reach its goal of reducing CO2 emissions by 25%.
Sound great. I'm going to get me some.
I thought you already went shopping. Anyway, before you go, let's find out the company president's motto.
This man's company makes products that are painted on for protection. So what would he do with ink?
はい、それを読んでいただいてですね、この文字に込められる意味を教えてください。
Do jobs you can be proud of for your children and your grandchildren. I think we should do good jobs, not just for ourselves, but also for those who follow us.
お父さん、おじいちゃん、立派な仕事してるねって思われるっていうのは大事ですよね。
Well, that's how I'd like to be regarded.
今日はどうもありがとうございました。ありがとうございます。
Insulating the environment for future generations. That's the legacy that Ishiko and his company intend to offer.